parallelograms, 4 sides. They're part of the quadrilateral family. They can have other shapes like squares, rhombuses, and rectangles in them. All of those are special quadrilaterals. So properties of parallelograms. This is the important part. This is what you're learning, because everything else, the math that goes into this, the calculation part, the equation part, is review. So a parallelogram is a quadrilateral, 4 sides, in which both sets of opposite sides are parallel. So both sets of opposite sides are parallel. So remember that as we're showing the notation for that we put these little arrows on the side like that. That indicates that that side is parallel. And then because the symbols match, that side is parallel. So you put matching symbols on both sides of the line to indicate which parts are parallel and which ones together that set means. So opposite sides are parallel. That's the first thing. Opposite angles are congruent. That means these angles are congruent, the ones that are opposite each other, and these two are congruent. Oh, I forgot a word. Opposite sides are also congruent. Because they're parallel, and we have 2 of them, and they have to come together. So these sides are congruent, and these sides are congruent. Remember, all those symbols mean is that since the symbol matches, so does the side. Same side angles are supplementary. So these 2 are supplementary angles. Remember, what does supplementary mean? How much do they add up to? (180 degrees). And the last part, diagonals bisect each other. So that means that this piece and this piece, and then this piece and this piece. So the number of lines there are important. Bisect means cuts in half. So each diagonal cuts the other diagonal in half. So that when you're trying to find values, and this is true for any parallelogram. So that means rectangle, square, and rhombus. All of those are parallelograms because opposite sides are parallel. So that's true for all of those. So once you know this property, that allows me, all I got to do is tell you 1 or 2 pieces of information, and you can solve for all of the angles, all of the sides, and even the lengths of the diagonals. So let's look at the first couple of parallelograms, and we're going to, are they yes or no? Is that a parallelogram?
Yeah.
Based on the information that you're given. Hey, Seuss, why is the first one a parallelogram?
Congruent sides.
'Cause-
Hold on. The opposite sides are parallel congruent.
So we don't know if they're parallel, but we do know they're congruent, right?
Yeah.
So it looks like they're parallel, but because they're congruent, that kind of means they have to be. Because they're the same length, the only way that works is if they're parallel, otherwise they wouldn't come together. So this is a yes. When we look at the next one, Stevie Ann, the next one, 130 and 50 and 130 and 50. Is that or is that not a parallelogram? Yes or no? Yes, because opposite angles, right here at the top of the screen, opposite angles are congruent. These are opposite and these are opposite and they're the same. So this is a yes. When we look at the third one, the 10s are good, but the 5 and the 6 are not. They have to, both sets have to be congruent. So this is a no. When I look at this, the fourth one, first of all, I don't know the opposite ones, so that doesn't help me right now. But what I do know is something about those. Those are supposed to equal 180. Do they? That's 115 or 215, right? Isn't that 215?
Yeah.
Because this is supposed to equal 180. So that's a no. The same side angles have to equal 180 degrees. When you look at the first one on the second row, the only information I have are the diagonals. But you'll notice that this is 7 and this is both 4. So this is a yes because the diagonals have been bisected. They've been cut into 2 equal pieces. But by the same token, when we look at the second one, these are the same. That's good. But 3 and 4 are not. So this is a no. Even though it kind of looks like it, because the numbers that we're given don't meet the properties, those are not parallelograms. So the information that's right here in words is what you need to learn from this section. Everything else is a review of how you solve for something, how you set it up an equation if you need to, how you take the information you have and apply it. This is the new information. These are the characteristics of a parallelogram. Both sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Same side angles are supplementary, which means they have to add up to 180 degrees. And the last thing is the diagonals bisect each other. So we're going to take those 4 or 5 properties and apply them in problems like this. So I noticed as we were taking the test the last time that naming angles and sides gets confusing for you. So we need to focus on that. So AD, that's a side. If there's nothing else above it, that's a side. So how long is this side?
180?
The angles would be, but we're talking about the side, the actual length of the side.
8.
8, because these are the ones that are opposite, right? So it has to be 8. And then DC is this side. It is opposite AB. So the length is 15. So then we need angle A. The only way I have to find that right now is to know that those two together have to equal 180. So this angle is 180 minus 68, which is 112, or yeah, 112. Is that right? Yeah. Okay, so if this is 112 degrees, how much is angle B? It is opposite here, so angle B is 68. And then angle C is 112. That's it. Once you can go through and you know the properties, then the calculation part generally isn't too hard. It's subtracting sometimes. So now let's look at letter B. JK matches ML. Those are opposite sides. So that means that it is 21. KL matches MJ. So that one's 29. K is opposite L, so that makes it 127. How do I find K?
Subtract
180 minus 127 is 53. Which means that M is also 53 because that is the opposite angle for K. All you're doing is comparing opposite sides and opposite angles in most cases. So it's important to note up here in the directions that each quadrilateral is a parallelogram. Oh, that means, Jacob, that means that all those properties apply. So when I look at this, it says that RT is 30. So because it's a parallelogram, how much is RV? If the yellow line is 30, how much is RV? Carlos? 15, because it bisects it. It cuts it into two equal pieces. So this is 15 and this is 15. It also means that VS is how much? 7, because it has to be the same as this one. I told you this piece, so it has to be the same. And then UT, if this top piece is 27, then so is the bottom piece. And if this is 18, then this is 18. So now that I've labeled it on my diagram, I can go answer the questions. That's how I like to solve these problems. If it works better for you to do it a different way, by all means. But I like to label in the diagram and then go figure out what I need. So UT is right here, so that's 27. ST is right here, so that's 18. VS, 7. And VT, 15. The only way you know how to solve that is if you remember those 5 properties. Parallel, opposite sides parallel, opposite sides congruent, opposite angles congruent, same side supplementary, and diagonals bisect each other. But then, the hardest thing we had to do was divide by 2. Let's look at D. So this one's going to take a little bit more, and it has the three-letter angles that seem to concern you. Just remember to follow them in order. So FED is 134. Here's FED. So that's 134. That means the 71 is for FEG. So this whole piece is 134. So then FCD is also 134. How much is EDC? These two together have to equal 180. So this is 180 minus 134, which is 44 degrees. 46 degrees. That also means that CFE is the same thing. I don't know if I need that yet, but at least I have it. So now I know that this angle is 46 degrees, but this piece is 21. So this piece is 46 minus 21, which is 25 degrees. And that's angle, watch how it goes, GFE. Now back to parallel lines. Remember we talked about when we had a transversal that opposite ones were congruent. So those are the ones. That means this is 21 and this is 25. Same thing is true here. If this is 71, then so is this one. And then to find color that one. And then to find FCG, that is (134 minus 71), which is 63. So this is 63, which means this is 63. So now I found all the angles in the shape just by either subtracting from 180 or subtracting from the other half of the angle that's there. Now I have to just make sure I can identify DEC. So DEC is right here. That is 63. So you just start with the first letter, C, D, E. How much is this? It's both of them, so how much is that? 46. And then we have E, C, D. Oops, do it again. E, C, D. That's 71. And then we have D, F, E. 25. So when you name an angle, there's a starting point where you turn and where you go back, or where you end. So start, turn, end. So as you label angles, or as you trace your fingers along, this is C, D, F. Or F, CE. Get in the habit of using your pencil to trace the angle as you name it, because you need to be able to identify where ECD is, and it's hard for me to do it without physically tracing ECD, without physically tracing it like that so that I can see where it is. All right, last one. And then you're going to do the problems on the back. How much time I got? Plenty of time. Okay. So I give you all these measurements, and I want you to find the rest of them in this parallelogram. Remember that the directions at the top of this section said that all of these shapes are parallelogram. So that means I know that they're congruent, I know what's supplementary, I know what's bisected, like all of that stuff is part of the problem. So first we go through and label everything. So XY is 15. What else is 15? WZ. So I'm just going to go ahead and do it now because it makes sense to do it as I go through. So I've done this one. WX is 22. So that means that ZY is 22. ZX, so ZX, that's this whole line, is 32. So what do I want to do with that information? Break it, you're right, break it in half, right?
Yeah.
Immediately. I don't want to do anything else. That's already, I know that each of these is 16 because ZX doesn't match anything else in the shape. But I know it's bisected. Like the diagonals are not even or equal, but I know that it's bisected, so I can get that right away. So then WT is 10. Here's WT. So what else do I know is 10? TY. Now here's where it gets a little trickier just because of shape and size. So W, Z, Y. So the big angle is 62 degrees. So the whole thing is 62 degrees. That means that WXY is 62 degrees. I don't know anything, the angles aren't bisected. I don't know anything about that. So far that's all I know. But I can use that information to find this angle and this angle. So this one, ZYX, is 180 minus 62, which is 118 degrees. Which means that ZWX also is 118 degrees. So both of these are 118. Then it says WXT. So this little half in here is 27. That means that WZT, nope, not WZT. If this is 27, then TZY is 27. TZY is 27. So that's this piece. And then ZWT, so this piece is 77 degrees. So that means this piece, which is TYX, is 77 degrees. Now I'm going to have to find this piece and this piece just because you know you are. You know you're going to be asked to find every piece of the angle. So remember that this whole big one outside is 118 and this little blue part is 77. So 118 minus 77. Where's my calculator? It's 41 degrees. So that means that this angle right here, which is ZYT equals 118 minus 77, which is 41 degrees, which means this is XWT. And then for the last one, this one is 62 minus 27, which is 35. And that's angle WZT and YXT. And I ran out of room to write angle. So now all I've done is put it all on the picture. So all we've done is identify where it is on the picture. And then I just have to go back and figure out what the labels mean to be able to identify it in the thing. So when you look at angle names, so I called this angle right here YXT. YXT. I can also call it TXY. I can call it YXZ. Like any start, turn, and end point on here, either direction works. So when you're looking at these, you're looking at the order of the letters, like XWT or TWX. Frontwards or backwards for that works. So now, you have all the numbers that we need. Looking at just this side, where is ZW? How much is that? ZW,
Oh, sorry,
15, right there. And ZY, 22. And TX, 16. And WY, now be careful, the whole thing is how much? This is 10, it's 20, that's right. So they just want you to know that that's how we bisected it and then add them together, so this is 20. Okay, now we're going to look at angles. This is a little bit more complex just because there's a lot of stuff on one picture. TZY. TZY. That's the orange one. The orange one was 27. X, Y, Z. X, Y, Z, that's 118. X, W, T. That's the green one. The green one was 41. And then X, Y, T. That's the blue one. The blue one was 77. So I'll say it again. I have pens that have 4 colors, black, red, green, blue, that you can use. I have highlighters. There's colored pencils. it would be really helpful to you as you label these to have multiple colors, because then you can keep track. Because doing it all in pencil or doing it all in pen, then you're like, well, which one matches? And so the colors really make it easier to determine that.